Your heart speeds up when you run, slows when you rest, and quietly reshapes itself over time in response to how you move. This constant adaptation is not random. It is one of the most carefully regulated processes in human biology, happening every second without conscious effort. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we are exploring how exercise impacts your heart, not as a fitness trend, but as a biological force that has shaped human survival for thousands of years. Long before modern science, ancient civilizations noticed the link between movement and vitality. In ancient Greece during the 5th century BCE, physicians like Hippocrates observed that physically active individuals often showed greater endurance and recovery from illness. However, the heart itself remained mysterious until the early 17th century. In 1628, working in London, English physician William Harvey published De Motu Cordis, proving that the heart functions as a pump circulating blood through a closed system. This discovery laid the foundation for understanding how physical activity alters circulation rather than creating or consuming blood. As exercise begins, the body's demand for oxygen rises almost instantly. Sensory receptors in muscles detect increased activity and signal the brainstem, which activates the sympathetic nervous system. Within seconds, the heart rate accelerates and stroke volume increases, meaning each beat pushes more blood forward. Studies conducted in the early 20th century at Harvard University by physiologist Lawrence Henderson confirmed that cardiac output can increase 4 to 6 times during intense exercise, supplying working muscles with oxygen and nutrients at extraordinary speed. Over repeated bouts of physical activity, the heart does not simply work harder. It changes structurally. In the mid-1900s, Swedish cardiologist Per-Olof Ostrand documented how endurance training enlarges the left ventricle, allowing it to hold and eject more blood with each contraction. This adaptation, known as physiological cardiac hypertrophy, differs fundamentally from disease-related enlargement. The heart walls grow stronger while remaining flexible, improving efficiency rather than impairing function. Exercise also reshapes the heart's electrical system. In the 1970s, researchers at the Karolinska Institute observed that trained athletes often have lower resting heart rates, sometimes below 50 beats per minute. This bradycardia is not a weakness. It reflects enhanced parasympathetic control, allowing the heart to maintain circulation with fewer beats. Each contraction becomes more powerful, conserving energy while sustaining blood flow. Beyond the heart muscle itself, exercise transforms the blood vessels connected to it. Repeated increases in blood flow stretch arterial walls, stimulating endothelial cells to release nitric oxide. This molecule, identified as a key vascular regulator in the 1980s by Robert Furchgott and later confirmed by Luis Ignarro and Farid Murad, causes blood vessels to widen. Over time, this improves arterial elasticity, reducing resistance and lowering resting blood pressure. Capillary networks also expand in response to training. Muscle biopsies performed in the 1960s at the University of Copenhagen revealed that endurance athletes possess significantly higher capillary density than sedentary individuals. This increased network reduces the distance oxygen must travel to reach muscle cells, easing the heart's workload during activity and recovery. Exercise influences the heart not only through mechanics, but through metabolism. During sustained physical activity, the heart shifts fuel use, relying more efficiently on fatty acids while preserving glucose for high-demand tissues. Research at the National Institutes of Health in the 1990s demonstrated that trained hearts produce more mitochondria, the energy centers within cells, allowing sustained output with less metabolic strain. Importantly, not all exercise affects the heart in the same way. Resistance training produces brief spikes in blood pressure as muscles contract, while aerobic exercise creates prolonged increases in cardiac output. Both forms stimulate adaptation, but endurance training more strongly enhances ventricular volume and vascular flexibility. This distinction became clear through echocardiographic studies conducted in the 1980s across European sports medicine laboratories. The heart also responds differently across the human lifespan. In children and adolescents, exercise supports normal cardiac growth and coordination. In adults, it preserves elasticity and metabolic efficiency. In older populations, Studies from the Framingham Heart Study show that regular physical activity slows age-related declines in heart function, reducing the risk of cardiovascular disease even when started later in life. Crucially, these benefits arise not from extreme exertion, but from consistency. The heart adapts to repeated signals, not occasional strain. Excessive training without recovery can overwhelm regulatory systems, leading to rhythm disturbances or inflammation. This balance was highlighted in longitudinal athlete studies published in the early 2000s, reminding researchers that adaptation depends on measured stress followed by repair. Seen through this lens, exercise becomes a biological conversation. Each movement sends information to the heart, instructing it to strengthen, coordinate, and refine its response. Over weeks and years, these signals reshape anatomy, chemistry, and electrical timing, turning motion into memory within cardiac tissue. The heart does not grow stronger simply because it is forced to work. It grows stronger because it is guided by feedback, adjusting force, rhythm, and recovery to meet demand without excess. Exercise teaches the heart how to balance effort with efficiency, moment by moment. Understanding this reveals why physical activity protects the heart beyond calories burned or muscles built. It preserves adaptability, the ability to respond smoothly to stress without damage. In a changing environment, this flexibility is what sustains life. The impact of exercise on the heart is not dramatic in any single moment. It is written slowly, beat by beat, as movement teaches the heart how to endure. This is Mattermosaic, piecing together the universe, one discovery at a time. If seeing how motion reshapes the heart changed the way you think about exercise and survival, share this insight with someone curious about the science beneath everyday movement, and stay with us as we continue exploring the forces that keep life in balance across the fabric of reality.